At 3:47 p.m. on July 2, 1944, Sergeant Curtis G. Cullen stood beside his disabled Sherman tank in a muddy field near Saint-Lô, France. His tank had just tried to crash through a hedgerow, one of the thick earthen walls covered with vegetation that divided every field in Normandy. The tank had climbed the hedgerow as intended, but as it crested the top, its belly armor was exposed to German anti-tank fire. A Panzerfaust had struck the vulnerable underside, penetrating the thin armor and disabling the tank. Curtis and his crew had escaped, but they'd lost their third tank in 2 weeks to the same problem. The hedgerows of Normandy were killing the Allied advance just as effectively as German tanks and artillery. American forces had been fighting in the Bocage country for 4 weeks since D-Day, and progress was measured in hundreds of yards per day. The hedgerows were ancient field boundaries, some dating back to Roman times. They consisted of earthen banks 4 to 6 feet high, topped with dense vegetation and mature trees. The roots formed a thick, tangled mass that was nearly impenetrable. When American tanks tried to push through hedgerows, they had to climb the bank. As they crested the top, the tank tilted upward, exposing its thinly armored belly to enemy fire. German soldiers with anti-tank weapons waited in the next field, knowing exactly when the vulnerable moment would occur. Dozens of American tanks had been destroyed this way, and crews were becoming reluctant to advance. The Allied commanders had not anticipated the hedgerow problem. Intelligence maps showed Normandy as agricultural land, but they hadn't conveyed how impenetrable the hedgerows were. Each hedgerow-enclosed field became a separate fortress that had to be cleared individually. Engineers had tried using explosives to blast through hedgerows, but this was slow and consumed enormous quantities of explosive. Bulldozers could push through, but they were vulnerable to enemy fire and there weren't enough of them. Curtis had been thinking about the hedgerow problem for days, and as he examined his destroyed tank, an idea formed. What if tanks could cut through hedgerows at ground level instead of climbing over them? They needed some kind of cutting blade mounted on the front of the tank that could slice through the roots and soil. Curtis looked around the battlefield and saw dozens of German beach obstacles scattered across the fields. These were the steel anti-invasion barriers that had lined the beaches on D-Day, nicknamed Czech hedgehogs. They consisted of heavy steel rails welded together in a cross pattern, designed to stop landing craft. The steel was thick, strong, and already cut into various lengths by Allied demolition teams. Curtis realized this scrap steel could be welded to the front of a Sherman tank to create cutting prongs. The prongs would dig into the hedgerow base, and the tank's weight and power would drive them through the roots and earth. What happened over the next 3 weeks would prove that Curtis's improvised hedge cutter could break the Normandy stalemate. Would show that battlefield scrap metal could solve a problem that had stumped Allied planners. Would eventually be installed on over 500 tanks and enable the breakout from Normandy. Curtis Cullen was 29 years old in July 1944. He'd been born in Cranford, New Jersey in 1915, the son of an automotive mechanic. Growing up around his father's garage, Curtis had learned welding, metalworking, and mechanical repair. He'd worked as a machinist before joining the Army in 1940. Curtis had volunteered for armored forces and trained as a tank crewman at Fort Knox. He'd been promoted to sergeant and assigned as a tank commander in the 2nd Armored Division. His division had landed in Normandy on D-Day +3 and had been fighting in the Bocage ever since. The 2nd Armored Division was one of the first American armored units to encounter the hedgerow problem. They'd expected rapid advances across open terrain, similar to armored operations in North Africa. Instead, they found themselves fighting yard by yard through a maze of small fields surrounded by impenetrable barriers. The hedgerows turned Normandy into ideal defensive terrain. German forces could defend each field with minimal troops, using the hedgerows as ready-made fortifications. Machine gun positions covered the narrow gaps between hedgerows, and anti-tank teams waited in concealment. American infantry could infiltrate through gaps, but tanks couldn't follow to provide support. When tanks tried to force their way through, they became easy targets. By late June 1944, the Normandy campaign had bogged down. Allied forces held a beachhead, but they couldn't break out into open country. The hedgerows were costing lives and time, and senior commanders were desperate for solutions. Various proposals had been tried or considered. Combat engineers experimented with using explosive charges to blow gaps in hedgerows. This worked, but required large amounts of explosives and was dangerous to the engineers. Each gap took 30–45 minutes to prepare, which was too slow for armored operations. Some units tried using tanks to push through hedgerows by brute force. This occasionally worked on thinner hedgerows, but usually the tank just climbed the embankment and exposed its belly. Tank commanders learned to approach hedgerows at angles, trying to minimize exposure time. But this was risky and didn't solve the fundamental problem. Artillery bombardment could destroy hedgerows, but this required massive fire concentration. The artillery couldn't support every tank advance, and the bombardment alerted the Germans to where attacks were coming. Curtis had experienced all these approaches and knew they weren't adequate. On July 2nd, after his tank was destroyed, Curtis went looking for his battalion's maintenance section. He found them in a field about a mile behind the front lines, repairing damaged tanks. Curtis explained his idea to the maintenance sergeant. Weld steel prongs to the front of a tank to cut through hedgerows. The sergeant was skeptical, but agreed to help fabricate a prototype. They needed steel that was strong enough to penetrate roots and earth without bending. Curtis walked across the nearby fields until he found a pile of German beach obstacles. These Czech hedgehogs were made from railroad rails, about 6 inches wide and incredibly strong. Using a cutting torch, Curtis and 2 mechanics cut sections of rail about 4 feet long. They cut the ends at angles to create sharp points. Curtis designed a mounting system, 4 steel prongs arranged horizontally across the tank's front. The prongs would be welded to the tank's lower glacis plate, angled slightly downward. When the tank drove into a hedgerow, the prongs would dig into the base of the embankment. The tank's 33 tons of weight, driven by a 450 horsepower engine, would force the prongs through the roots. This would create a gap at ground level that the tank could drive through without climbing the embankment. Curtis and the maintenance crew worked through the night of July 2nd–3rd. They welded the 4 prongs to a Sherman tank that had been repaired and was ready to return to service. The prongs extended about 3 feet forward from the tank's front armor. Each prong was spaced about 18 inches from the next, creating a 4-tine cutting tool. The additional weight was about 750 pounds, which the Sherman could handle without performance issues. On the morning of July 3rd, Curtis and his crew tested the modified tank. They found a hedgerow in a rear area where they could test safely without enemy observation. Curtis drove the tank directly at the hedgerow at moderate speed. The prongs hit the embankment base and dug in, just as Curtis had hoped. The tank continued forward, the engine straining as the prongs cut through roots and compacted earth. After about 10 seconds of pushing, the tank burst through the hedgerow. Curtis had created a gap about 8 feet wide at ground level. Critically, the tank had stayed level throughout the breakthrough, never exposing its belly armor. The prongs had torn through the hedgerow's roots, which were the main structural element. Once the roots were severed, the earthen bank collapsed and the tank could drive through. Curtis tested the device on 3 more hedgerows, each time successfully cutting through within 10–15 seconds. The prongs showed some wear but remained functional. Curtis reported his successful test to his company commander, Captain James DeFranzo. DeFranzo immediately recognized the significance of what Curtis had created. He ordered the device demonstrated to the battalion commander, Lieutenant Colonel William Duncan. On July 4th, Curtis demonstrated the hedge cutter to Duncan and several other battalion officers. They watched as Curtis's tank cut through 4 hedgerows in rapid succession. Duncan was impressed and immediately ordered the device installed on as many tanks as possible. He also reported the innovation to division headquarters. Word of Curtis's hedge cutter spread rapidly through the 2nd Armored Division. Battalion maintenance sections began fabricating copies using whatever steel they could find. German beach obstacles were abundant near the front lines, providing ready material. Within a week, over 60 tanks in the 2nd Armored Division had been fitted with hedge cutters. Tankers began calling the modified tanks Rhino tanks or Kulin hedgerow cutters. The name Rhino came from the way the prongs looked like a rhinoceros's horns charging forward. The first combat use of Rhino tanks occurred on July 11th during an attack near St. Lo. A company of Shermans equipped with Curtis's cutters led an assault through heavily defended hedgerow country. The tanks cut through hedgerows rapidly, maintaining momentum and keeping infantry support close. German defenders were caught off guard because they'd expected tanks to climb hedgerows slowly, exposing themselves. Instead, the Rhino tanks burst through at ground level, surprising defenders on the other side. The company advanced over 1,000 yards in 4 hours, a significant gain compared to previous operations. The success of this attack brought Curtis's innovation to the attention of 1st Army headquarters. General Omar Bradley, commanding 1st Army, personally observed a demonstration of the hedge cutter on July 14th. Bradley immediately ordered the device installed on every possible tank before the planned breakout operation. The breakout, codenamed Operation Cobra, was scheduled for late July. It would be a massive armored thrust designed to shatter German defenses and break into open country. The hedge cutters would be essential to the operation's success. 1st Army issued orders for mass production of Kulin cutters. Every maintenance company and ordnance unit in Normandy began fabricating the devices. Engineers scoured the beachhead for German steel obstacles to use as raw material. Welders worked around the clock cutting rail sections and welding them to tanks. The design was refined slightly based on early combat experience. Some tankers found that 6 prongs worked better than 4 for thicker hedgerows. Others added teeth or serrations to the prongs to improve cutting action. The mounting points were reinforced after some prongs broke off under extreme stress. Curtis worked with ordnance officers to document the design so it could be standardized. They created templates and specifications that ensured all cutters were built consistently. By July 20th, over 300 tanks had been equipped with hedge cutters. Approximately 60% of the Sherman tanks earmarked for Operation Cobra had the modification. Training was conducted to teach tank crews how to use the cutters effectively. Crews learned to approach hedgerows at moderate speed and maintain steady power as they cut through. They learned that the prongs worked best when hitting the hedgerow perpendicular, not at an angle. They also learned to watch for anti-tank fire from the far side once they broke through. Operation Cobra began on July 25, 1944, with a massive aerial bombardment. American armored divisions then attacked south through the bombed area. The Rhino tanks proved their worth immediately, cutting through hedgerows that would have stopped earlier attacks. Tank columns maintained momentum, advancing several miles on the first day. German defenses, weakened by the bombardment, couldn't establish new positions because American tanks were advancing too quickly. By July 30th, American forces had broken through the German defensive line. The 2nd and 3rd Armored Divisions exploited the breakthrough, racing into open country. The Normandy campaign entered its mobile phase, with American armored forces conducting deep penetrations. The breakout eventually led to the encirclement of German forces at Falaise and the liberation of France. While many factors contributed to Cobra's success, the hedge cutters played a crucial tactical role. They allowed armored units to maintain tempo and exploit opportunities that would have been impossible without them. After-action reports specifically cited the Kulin cutters as a major factor in the breakout's success. Tank commanders reported that the cutters allowed them to advance with confidence rather than hesitation. The psychological impact was as important as the tactical advantage. For his innovation, Curtis Cullen was awarded the Legion of Merit in August 1944. The citation noted that his ingenuity had contributed directly to the success of Operation Cobra. General Bradley personally presented the medal and thanked Curtis for solving a problem that had stumped senior planners. Curtis was also promoted to Technical Sergeant and later to Sergeant First Class. The hedge cutter story became legendary within the armored forces. It was held up as an example of soldier initiative and practical problem-solving. Military publications featured articles about the Rhino tanks, and the story appeared in Stars and Stripes. Interestingly, Curtis wasn't the only soldier who'd developed a hedge-cutting device. Several other tankers and engineers had experimented with similar concepts independently. A lieutenant in the 747th Tank Battalion had developed a similar device using scrap metal. An engineer company had created a blade attachment that also cut through hedgerows, but Curtis's design was the first to be widely demonstrated and officially adopted. His use of German beach obstacles as material was particularly clever because the steel was abundant and free. The Army gave Curtis credit as the primary inventor, though it acknowledged that parallel development had occurred. This is common in wartime innovations, where necessity drives multiple people toward similar solutions. Curtis continued serving with the 2nd Armored Division through the end of the war in Europe. He participated in the drive across France, the Battle of the Bulge, and the final push into Germany. He survived the war and returned to New Jersey in 1945. After the war, Curtis worked as a welder and machinist in civilian industry. He rarely spoke about his wartime innovation, considering himself just one of many soldiers who'd contributed. The hedge cutter design influenced post-war military engineering thinking. It demonstrated that field modifications using battlefield materials could solve tactical problems quickly. This lesson influenced how the Army approached obstacle clearance in subsequent conflicts. Modern military vehicles often include provisions for attaching various tools and blades for different terrain. Combat engineering vehicles carry specialized equipment for breaching obstacles rapidly. The principle of rapid obstacle clearance that Curtis demonstrated remains fundamental to armored operations. The Rhino tanks became iconic symbols of American ingenuity and adaptability. They represented the American approach to warfare: identify problems and solve them practically rather than theoretically. The story resonated with both military professionals and the general public. It showed that ordinary soldiers could make strategic contributions through creative thinking. In the 1970s and 1980s, military historians documented the Normandy campaign in detail. The hedge cutter story appeared in numerous books and documentaries about D-Day and the breakout. Historians like Stephen Ambrose and Max Hastings highlighted Curtis's innovation as a turning point in the campaign. Some historians argued that the hedge cutters were as important to the Normandy breakout as aerial bombardment or numerical superiority. They enabled tactical mobility that transformed the campaign from a grinding stalemate into a war of movement. The Smithsonian Institution's National Museum of American History has a section of hedge cutter in its collection. The artifact was recovered from a Sherman tank preserved at Fort Knox. The museum display explains how the simple device broke the Normandy stalemate. Visitors can see the thick steel prongs and understand how they cut through earthen embankments. The National WWII Museum in New Orleans features the hedge cutter story prominently in its Normandy exhibits. They have photographs of Rhino tanks and oral histories from veterans who used them. The museum's interpretation emphasizes how the innovation came from field necessity rather than planned development. Curtis Cullin died in 1963 at the age of 48 from complications related to war injuries. His obituary in the Newark Star-Ledger mentioned his Legion of Merit and his famous innovation. The obituary noted that Curtis had been characteristically modest about his contribution. He'd always maintained that he'd simply done what needed to be done with materials at hand. In 1984, the Army Tank Automotive Command named a building at the Detroit Arsenal, the Cullin Building, in his honor. The dedication ceremony included veterans of the 2nd Armored Division who'd used Rhino tanks in Normandy. They shared stories about how the hedge cutters had given them confidence to advance through the bocage. Several veterans credited Curtis's invention with saving their lives by preventing their tanks from being disabled. The comparison between Curtis's achievement and other wartime innovations reveals common patterns. Like the other innovators in these stories, Curtis succeeded by understanding the fundamental problem. He recognized that climbing hedgerows exposed tanks to fire, so the solution was to cut through at ground level. His innovation was identifying German beach obstacles as the perfect material for cutting prongs. The steel was strong, abundant, and already cut into manageable sections. Curtis's background as a machinist and welder was crucial to executing his idea. He knew how to work with steel, understood welding techniques, and could visualize how the device would function. Another important aspect was Curtis's willingness to act on his idea rather than just proposing it. He didn't submit a suggestion up the chain of command and wait for approval. He built a working prototype and demonstrated that it actually worked. This hands-on approach was more convincing than any written proposal could have been. The rapid adoption of Curtis's device demonstrates how quickly good ideas can spread in wartime. Within 3 weeks, his concept went from initial test to installation on hundreds of tanks. This rapid implementation was possible because the design was simple and used available materials. More complex solutions would have required factory production and longer implementation times. The hedge cutter story also illustrates the value of empowering soldiers to solve problems. Curtis was a sergeant, not an officer or engineer. He didn't have formal authority to modify military equipment, but his officers recognized the merit of his idea and supported its development. This bottom-up innovation was more effective than top-down directives could have been. The psychological impact of the hedge cutters deserves special attention. Before the Rhino tanks, American tankers approached hedgerows with fear and hesitation. They knew that crossing a hedgerow meant exposing their tank to almost certain enemy fire. After the cutters were installed, tankers gained confidence. They could advance aggressively, knowing they wouldn't be helplessly exposed. This psychological shift was as important as the tactical capability the cutters provided. The German reaction to Rhino tanks revealed how the innovation affected enemy morale. German defenders in the bocage had relied on the hedgerows as force multipliers. Small numbers of troops could hold large areas because the terrain favored defense. When American tanks began cutting through hedgerows rapidly, German defensive doctrine was disrupted. They couldn't predict where tanks would breach, and their ambush tactics became less effective. This contributed to the collapse of German resistance during Operation Cobra. In thinking about Curtis Cullen's legacy, several important themes emerge. First, the value of practical skills. Curtis's welding and metalworking background enabled him to turn an idea into reality. Second, the importance of using available resources creatively. Curtis didn't wait for factory-made solutions. He used battlefield scrap metal. Third, the power of demonstration over proposal. Building a working prototype was more effective than writing a recommendation. Fourth, the critical role of leadership that supports innovation. Curtis's officers could have dismissed his idea, but they recognized its merit and promoted it. Finally, Curtis's story shows that individual soldiers can impact strategic outcomes. One sergeant's innovation enabled an entire army to break through defensive lines. Curtis Cullen was a tank sergeant with welding skills and mechanical knowledge. He wasn't a general or a famous engineer, but when he saw his fellow tankers dying trying to cross hedgerows, he refused to accept it. He looked at battlefield scrap metal and saw a solution to a problem that had paralyzed an army. His hedge cutters transformed the Normandy campaign from a stalemate into a breakthrough. That's the essence of practical innovation. See the problem clearly, use available resources, and build something that works. If you found this story as inspiring as we did, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these untold histories, because each story reveals something important about courage, ingenuity, and the power of individual initiative. And we'd love to hear from you, so leave a comment below telling us where you're watching from. Thank you for watching, and thank you for keeping these important stories alive.